Hey Matadors, today we're going to be doing a lab with lenses. I purchased some lenses off Amazon, so you'll be able to see the lenses. Hopefully I'll do my best to show you what I'm seeing through my camera, and we'll get to explore concave and convex lenses and see what kind of image that we see at certain distances. So let's get to it. Here's the set of lenses that I ordered. You can see that all the ones along the top are concave lenses, and all the ones on the bottom here are convex lenses. And then you say, why would I order so many lenses? Well, if you look carefully, all of them are 50 millimeters wide. That's talking about how their diameter from edge to edge. So they're all this same size, 50 millimeters, I apologize. This size. The only difference is the focal length. So 20 centimeters, 30 centimeters, and 50 centimeters for focal length. And if you do the virtual lab, you'll understand what it means by focal length. So I'm going to choose today to use... Okay, today's lab we're going to look at how do lenses affect how an image is seen. Light changes direction as it passes through a medium, and one medium that is used to change the direction of light is called a lens. And we're looking at two different lenses today, a convex lens and a concave lens. Now these lenses can be found in eyeglasses, cameras, telescopes, and binoculars. But how does the shape of the lens and the distance of the lens from the object affect the image that you're going to see? So let's investigate. So here's some lab some materials that you're going to see that I'm going to be using. I'm going to have a note card in which I'm going to attempt to have an image appear on this blank white note card, or you could do a piece of paper. I think I used an envelope for mine. I do have my different types of convex and concave lenses. I'm going to show you those in a moment. I have a book that I'm going to attempt to look at, and we'll see what image we see through the lens. And then I have a meter stick in order to measure the distance. Now I have different kinds of lenses, and the focal lens that I'm going to be using today is a 30 centimeter focal length lens. The first thing you're going to see me do is I'm going to prop up my book. I'm going to hold the convex lens. That's the lens we're going to start with, is the convex lens. I'm going to hold it at arm's length away from my eye and the camera, and I'm going to be about 1.5 meters from the book, and I've measured that out. We're going to look at the book through the lens, and I want you to record the observations. What do you see? I have video and still pictures, and I want you to record your observations. What does the book look like through the lens at this 1.5 meters away from the book? Okay, for today's experiment, we're going to be using Percy Jackson, the Titan's Curse, which is the third book in the series. My son is reading it right now, so I went and got it at Barnes & Noble. If you're running low on books, you can order from Barnes & Noble, and you just drive by and they throw it in your car. It's pretty cool. So as you can see, there's 1 meter away from the book, and there's 1.5 meters, and I am using my convex lens here. So I'm going to hold it up, and this is hard to see. I'm going to hold it at arm's length here, try and see what image do you see. Oh, I'm going to try and focus on his head there. Oh, there's his head and the wings of the creature that he's on. How would you describe this image going on here? I'm going to try and find where the Percy Jackson title, there it is. I'm just going to move it around here. What do you notice is what you see the image in the lens? What does it look like? What would you say it is doing? Write down your observations. Now I'm going to slowly move the camera toward the book, still keeping the lens at arm's length, and once I see that the image changes significantly, I'm going to stop, and then I'm going to measure the distance that my lens is to the book, okay? And I will show you me measuring that. And then you can write any observations that you're seeing through the camera right here, and then we'll also record the distance. So here we are at 1.5 meters away from the book, the lens and the book. So I'm going to start taking some steps closer, trying to keep my lens focused on the book. It's very difficult trying to keep that focused. It's much easier without holding a camera, but we're trying to see if the image in the lens is doing anything. It appears to be still inverted and upside down as I catch a glimpse of the head of Percy Jackson on the cover of this book. And as we get closer and closer, I'm going to try and see if anything significant is happening to the image as we move closer and closer and closer. I'm going to try and focus in on his head. And as I start to find his head again, I can see that it has changed a little bit. So I'm going to try and find that head, focus it one more time. And there it is. Wow, look what's happened now. It is now right side up. So I'm going to step back a little bit and see if I can see when this image, at what distance exactly it decided to go from being inverted to flipping around to right side up. So I'm just going to try and move a little bit forward and a little bit back, trying to see where this sweet spot is that the image is now reversing from being inverted to being upright. And as soon as I find that spot, I'm going to stop and take a measurement. So here is a still picture of the inverted image right before it flips. And here it is right afterwards, so I'm going to set this down and measure. So I know this isn't perfect, but I put a line on the spot approximately where my image of my Percy Jackson book went from being inverted or upside down to being right side up. And as we look in here, about how many centimeters is that? It's about 59 centimeters. Remember, here's our centimeters and here's our inches. We don't want standard measurement, we want centimeters. So let's go ahead and write that in our book. All right, the next thing we're gonna do is we're gonna go inside my house, and I'm gonna make the lights pretty dimmed inside, and I'm gonna open up my shutters in front of a window, and I'm gonna hold the envelope, the white note card I have, in front of the window, and I'm gonna put the camera up there too so you can see what's happening as I hold the lens between the card and the window. Now I'm gonna actually try and focus an image of my scene outside. It's gonna be my front yard and my neighbor's house across the street and some trees out front onto the card by moving closer and farther away, the lens and the card. I'm gonna try and move those. So when the image is focused as nearly as possible, I am gonna measure that distance between the lens and the note card, and I'm gonna record that data right here, okay? And once again, this is for convex lenses. All right, I'm using my convex lens here. I've got darkened my room, and I have a window right behind the camera. And so I'm gonna bring in my lens, and you'll see an image up here on the paper. It's a little blurry, but as I move the lens closer to it, it becomes clear. It's my neighbor across the street and the trees out in front of their house. And so I'm gonna see the grass and my driveway. So as I go forward and backward, it's gonna get blurry and then come into focus, and then it's gonna get blurry again as I move further and further away. So I'm gonna stop when I get to the part where it is most clear. Looks like it's about right here. I'm gonna stop and I'm gonna measure that right there. All right, I held my paper at about 80 centimeters, and when I brought my convex lens in, the spot at which the image from outside became clear was when I hit about 50 centimeters. So if we subtract 80 minus 50, we see that that is 30 centimeters. And imagine that I am using a 30 centimeter focal lens, convex lens. So once again, at 30 centimeters is when that image from outside became clear and wasn't blurring anymore. So now that we've done all of those with a convex lens, we're going to switch over to a concave lens, and I'm going to do those three things once again. I'm going to show you them right here. First, we're going to start with just what the image looks like at 1.5 meters away from the book through a concave lens. And then I'm going to walk slowly toward the book, and you're going to see write any observations how the image changes at any point, maybe measure distance. And then we're going to go inside again and try and focus the outside scene onto the white card and see what we observe there, and we'll write our observations right here. So now I'm going to do the exact same thing, but now with my concave lens, also 30 centimeters. I'm going to move slowly towards the book and see what happens. It's a lot easier to see this image for sure. Oops, there we go. We're going to keep going till we see something happen. Ooh, weird, huh? Don't really see much of a difference here until we get really, really close. All right, I'm doing one more recording with my concave lens, trying to bring an image. So I'm trying to get an image from outside. Got my concave lens right here, and I'm trying to create an image onto the card. And I can't seem to get any sort of outside image onto the card. All I see are shadows and some reflections, but nothing that was like the other lens. Definitely no scene from outside. No matter which distance, I can't seem to get anything to come up on the card. Nothing. All right, we're just gonna review our observations of this lab. So our convex lens we saw had an inverted image of the book, and it was blurry at 1.5 meters. As we moved closer, the image became more and more clear, but it did go from being inverted or upside down to upright at about 59 centimeters, which is really close to 60 centimeters, which is about 2 focal lengths, because we were using a 30 centimeter focal length lens. Now when we went inside, we saw that the image onto the card, it went from being blurry to clear as you increased or decreased the distance of the lens and the card. So kind of like what you do when you focus with a camera. Now the image was inverted, it was upside down. So if you want to draw a picture of what you saw in my picture, you can do that, or you can try this if you have a convex lens at home. Now when we switched over to the concave lens, we saw that at 1.5 meters, all we saw was that the image looked smaller than a real object, and the image was upright, it was not inverted. And as we walked slowly toward it, the image really stayed the same. It stayed small, it stayed upright, it didn't flip at all. There wasn't any specific distance at which it significantly changed. And then when we tried to go inside and project that onto a card, there really wasn't, it didn't project into a small image onto the card from outside. It didn't bring in the rays of light to focus on the card. All we saw were reflections of virtual images, which brings us back to lesson 2 when we looked at curved lenses and how the reflection of light can bounce back off of curved lenses, and those create virtual images, which you saw, but they weren't really in front of you. They were things that were behind you. So then we go to analysis and conclusion, and I'd like you to answer this question. To identify the positions of each lens, concave and convex, in which you saw any significant changes in the image, any major changes, and any thoughts about why you think these were caused. We're going to read about this next week.